Hi, this is Mr. Warden. This is the Geometry Exit Ticket 35.1 video key. So let's get to it. So our first question involves finding the length of OP. So what is the length of OP? So let's consider the information that we have. Now, what can we assume also about OTP based on the postulates from the do now? Okay, so let's go ahead and deal with that. So we can assume that that's a right angle, because TP is tangent to circle O at T. And the radius of circle O comes into contact with a tangent. So radii come to the point of contact with a tangent line will make a right angle with a tangent line or line segment. We know the radius of the circle is 8 millimeters, and we know that TP is 6 millimeters. And wow, is that not to scale? But we have a right triangle, and this hopefully you will recognize as part of a Pythagorean triple family, the 3, 4, 5 family. So this is 3 times 2, this is 4 times 2. So this will be 5 times 2, or 10 millimeters long. All of these are, of course, millimeters. They are not badgers, they are millimeters. So OP is going to be 10 millimeters long. Now, the next one is a little more involved, but it will involve a parallel line of the Pythagorean theorem. So we want to find the length of the common external tangent AB, also known as x. The length is x. So we're trying to find x. Oh, there it is. Cool. So hint, a parallel line of the Pythagorean theorem will be useful to us. So we know the radius of circle P is 8. We know the radius of circle Q is 18. So here is my recommendation. We make a line that is parallel to AB, and that is the most amazing parallel line you have ever seen. Okay, so since it's parallel, and since this is a right angle, and this is a right angle, then this is a right angle, and so is that. Okay. So, and this length here is x. So we're going to find x of this, and then we'll know what that is. We've made a rectangle. So this side is 8, and then we'll have a side here that's 8, and which means that this part here is 10. Then we're going to connect the radii like that. And since this radius is 18, this radius is 8, we can put those together and we get 26. So from here to here is 26 centimeters, of course. Okay, so 18 plus 8 is 26. So now we got 10 and 26. This is a hypotenuse. We're trying to find the long leg of this triangle that's 10 and 26. Now you may recognize this as a Pythagorean triple family. 10 and 26 are the double of 5 and 13. And there is the 5, 12, 13 triangle in the Monk's Pythagorean triples. So x is, and so these are double 5 and double 13. So x should be double 12. So x should be 24 centimeters. Okay, I want to review that procedure. This is kind of a common procedure for the common external tangent measurement. So what you do is you draw a parallel line from the smaller circle's center to a radius for the other circle. If radii are not drawn, first draw the radii to the points of tangency or the points of contact. Okay, that line will end up being parallel and congruent to the segment of the common external tangent. Then if you know the radius for the larger circle, then you can split it up into 2 parts, and you'll know this side of this right triangle. If you know the radii of both circles, then you can combine them to make the hypotenuse of a right triangle. And with the Pythagorean theorem, we can work out what x is, which is the same as that x. So 26 centimeters is our length. Okay, so I'm sorry, 24. What am I saying? 24 centimeters. Okay, so x x equals 24 centimeters. And I hope that was helpful.